Okay. Here is our first encounter, well, our second encounter with series, and today we're going to talk about the nth term test, which is basically your most simple test. Essentially, to stand a chance for a series to converge, the limit has to go to 0. So we have the nth term test for divergence. If the limit does not go to 0, sorry, then the series automatically diverges. So if we were to take the limit as n goes to infinity of 2n, you would say that that goes to infinity. Because that does not go to 0, then the series diverges. If we look at this one, the limit as n goes to infinity is 1/2. So this series will diverge. So if we look at 1/3 to the n, the limit goes to 0. Okay, so the test for divergence fails. We know nothing. So because the limit as n approaches infinity of 1/3n is 0, then we can't say that it diverges. So at this point, it might converge. What we find out a little bit later when we do the p-test is that there's a rule that says if you have 1/n to the p, if p is greater than or equal to 1, if p is greater than 1, it converges, and if p is less than or equal to 1, it diverges. So because this is like 1/3n to the 1, this would actually diverge. Okay. We're trying to still figure out if it converges or diverges. So if we do the limit as n goes to infinity, this goes to 1/3. 1/3 is not equal to 0, so it's going to diverge automatically. This one, the degrees here are the same. A factorial over a factorial is going to grow at the same rate. So that's the limit is 1/3, so that's actually going to diverge as well. It says try these before you watch the next video, so just pause it for a second and see if you can do them, and then we'll look at them. So pause. Okay, you should have tried these already. This one, the limit goes to 1/3, because that's not 0. This is going to diverge. This one, if we fill in, if we think about the graph of tan inverse as it goes to infinity, I don't know if you remember this from pre-cal or not, the graph actually looks like this. Tan inverse is defined between -pi/2 and pi/2, and that's all. As we go to infinity, as we go as far as we can possibly go, it goes to pi/2. Because that limit is not 0, it's going to diverge. This one is actually a geometric series, because you could rewrite that as 1 to infinity of e/3 to the n. And that's about, remember, e is 2.7182, 8, 18, 28, 45, 90, 45, and then comes 23. So this is like 2.78/3 to the n. That's a geometric series. Remember that geometric series converge if the absolute value of r is less than 1. Well, r is 2.78/3, which is less than 1, so it is going to converge. So we would do, because 2.78/3 is less than 1, that's going to converge. So, and remember that geometric series converge to the first term over 1 minus the common ratio. So my first term, if I fill in a 1 here, would be e/3 over 1 minus my common ratio. Well, that's r. So it's just e/3, which is whatever that ends up being. You can leave it like that. This one, the limit does go to 0. The nth term test does not apply, so just by the nth term test, I know nothing. But because you could have just stopped and said the nth term test doesn't apply, but because I know that this is kind of a p-series where p is 1, it is going to diverge. This one is, the limit does go to 0. So as far as the nth term test is concerned, you know nothing. This is a special type of series. It's called a telescoping series. It can actually, if I decompose it into partial fractions, it ends up being 1 over n minus 1 over n plus 1. And if you just work your terms out, if you fill in a 1, you get 1 over 1 minus 1 over 2. Plus, if you fill in a 2, you would get 1 over 2 minus 1 over 3. Plus, the third term, you'd get 1 over 3 minus 1 over 4, etc., etc. Well, look what happens to the terms. Those cancel, and they would continue to cancel forever and ever and ever, so it's actually going to converge to 1. And we'll stop this one here and just look for nth term test part 2.